So, what's up, guys? So, this will be a playlist. This is the first video in my playlist of data structures in C. So, I will be putting up a video in a week or two. Now, this is the first video on linked list in C. Next will be of stacks and queues, I guess. And along with this video, explaining the concept, I'll also be uploading the source code on my website. Um, I will be posting the link in the description. The website is iamrajendra.pythonanywhere.com. There's a long story about this website. How did I get this subdomain .pythonanywhere? So basically, the site is written. The backend of this website is written in Python, and you know nowadays the server space is quite high. The servers that auto scale according to demand. So they just offered me a subdomain provided I use the free space. So I just took it. So as you all know, uh, this is the slideshow which we'll be using. Thanks to Dr. David Malon of Harvard University who let me use this PDF. And so let's get started. So in C, basically we have come across this data structure that is arrays. But there is a limitation to this kind of data structure. This is a heterogeneous data structure. You can store an data type of int or a data type of string, but the limitation is like if you need a extra block in this array, like we have 6 here, what if we need a 7th block? So we need to create a new array, copy the contents of this array into the new array, and then there will be an extra block in the new array provided we declare it in the start of our code. So to solve these problems, we have various data structures like linked lists, stacks, and queues. So there are many pros and cons of linked list and arrays. Like we have randomness in arrays. If we want to access any random position in array, we have to just give the index. So this is not true in linked list. We have to traverse the linked list up to the end. So this kind of problems, we try to solve in time complexity and space complexity. So this will keep it for another video where we will be explaining about theta, omega notation, big O notation of time complexity of various algorithms. So let's get started with linked list. So basically, linked list looks something like this. In memory, it's a bit complicated. Like it's not like this underneath the hood. We don't have this consecutive memory blocks side by side in memory. Whenever we declare a data structure or use any kind of variables in our C code, it actually gets initialized in a heap. Heap is a part of memory which stores various variables. So this is not the case. Like we don't have continuous block in heap. We have some block in one corner, some other block in other corner, third block in middle or somewhere. Like I don't know where it is, but we can traverse the list using pointers. Yeah, pointers is a very strong concept. I like pointers because they give access to memory and you can do very much evil things with memory. So yeah, so this is the linked list which you can see on the screen. It has two blocks. One block stores data and the other block stores the address of the next node, so that if I want to access the data of the next node, I can follow up the pointer. uh, the end of the linked list is denoted as the earth symbol, that is the earthing symbol that extc people use, or electronics, I don't know what is that, but the earth symbol denotes that the block with data 34 points nowhere, it's null. So that is the end of the linked list, and here I have the variable called first, which points to the first node. So I know the start of the list and the end of the list, and the middle, all of the blocks addresses are stored in the next pointer variable. So basically this is a single node which we as call in linked list. This is a single node. It stores a data, and the memory part which stores the data is called n in this case, and the pointer, that is the address of the next node of this node, is stored in the variable called next. So I use this variable names to understand what it does. uh, so this is a single node represented. So can you guess? You can see on the screen that we need a struct to store this kind of, to create this kind of node which has a block of memory storing the name or a block of memory storing something else. So this is a node of struct student. We have used this many times in previous years, like writing C program to store data of student. So the similar way we will be using struct to define our linked list. This is the code that we use to initialize a node, that is to create a node in memory, to create a variable called node in memory. Typedef struct node int n struct node star next. As you can see, I can store the data in a variable called n and the address of the next node in a variable called next, which is a pointer to the same data type, that is the node. So these two lines of code tells us that give me a block of memory that stores an integer and give me another block of memory that stores the address of the next node. As we know, pointers also have data types. Like if we want a pointer to store an integer, we want the pointer of type int. So this is the pointer to store the address of the next node. Now we will be seeing the meaning of each word, that is typedef, struct node, and the node at the end. Consider it as the same struct that you have defined, like the struct student. So struct node is used in similar analogy as struct student. Typedef and this node, which is highlighted in yellow, is used to actually say to computer this that whenever I will be using a node, I will not call it as struct node n or struct student t in case of student. I will be just using a word node for defining my data type, like int n, int a, float b. So I will be just using this in the similar manner like node n or node a or node b. We have used this name for using the data type called node, like the int, and we have used this name node here so that this struct is self-referential while declaring this pointer. So this is the linked list. The first points to the first node and the end of the node is seen by the next pointer pointing to null, that is nowhere. Now inserting a node. So first we solve the problem of inserting at the tail. Now as you can see in the previous slide that this is 34, the end of the node. Now what if I want to insert a new data at after 34? So this is the new node that we created. Now we need to update pointers, right? Like the last node, the next pointer of the last node should point to null, that denotes that is the end of the linked list, and the previous node, which was the last node previous, should point to the new node. So this is the predptr, which is a temp like variable I used to traverse the list, and this is the new ptr, which this new ptr and predptr are the pointers to the respective nodes, as you can see in the diagram. So the predptr's next field, that is the pointer called next, to store the address of the new ptr, the new node that I have created, and the next pointer of the last node, that is a 55, which I inserted at the tail, should point to null, that is nowhere, and denote the end of the linked list. Now inserting at the head involves a bit of complexity, right? We need to update the first variable, first pointer, which stores the head of the linked list. The first variable stores the start of the linked list, so we need to update that, right? So predptr is currently defined in my code as null, that is pointing nowhere, and new ptr points to the new node that I created for inserting. Now the first points to the new ptr, and the next field of new pointer, that is a new node, should point to the next node. So in this way I insert a new node at the beginning by updating two pointers, that is the next field of the new node that I created and the first field, which should point to the start of the list. Inserting at the middle is by far the simplest mechanism to do. Like we need to just update the next pointer of the predptr, like insert at the middle. So we need to insert 20 between 17 and 22. So this is the new ptr, this is a pointer to the newly node that I've created, and predptr points the node after which I need to insert this new node. So new predptr points to 17 and I need to insert this node 20 after 17. So I need to update some pointers. I suggest you to pause the video and think like how are we gonna update the pointer without losing the contact of the other list nodes. The new next field of new PTR, that is a new node, should point wherever pred PTR's next points, right? Pred PTR's next field points to the next node, so this same address should be stored in the new PTR's next field, and then we update the pred PTR's next field to point wherever new PTR points, that is the memory address at which my node is created, the same way. So this is the inserting at the middle. Then of course if we need to insert, then we need to remove if we don't need the data anymore. Now malloc and free are the two lines, I mean the two keywords that we use. Malloc is used for allocating memory. Using a malloc statement tells the compiler like, hey compiler, give me a block of memory. So malloc returns the address of the newly created memory. And free just freeze, I mean just deletes that memory, just freeze the block. You need to use free and malloc. Many people say that it's a convention, but it's not a convention. Like, we need to use malloc and free to avoid memory leaks in our code. If we have memory leaks in our code, it generally slows down your computer. Like sometimes, whenever you use a software, it crashes randomly without any warning. So this is due to memory leaks. Maybe that software is using so much memory that your computer ran out of memory and it just got that program crashed and stopped. So removing at the tail, in the same case we need to update the pointer. So here if we want to remove at the tail, that is the 34, that last node we need to remove, so we need to update the pointers as well. So we free the block of memory that was used for storing 34, and the next field of the previous node, that is a pred PTR predecessor, pred PTR's next field should point to null, which shows the end of the list. That is the 34 is gone and now 29 is the end of the list. Removing at the head, this also involves a bit of complexity, so try to understand it clearly. Like, we need to update the first variable to point to the next node after removing the head. Now 5 is the head here and 9 is the second node, so we need to remove 5. We are going to free 5 and update the first pointer to point to 5. So first should point, that is the first, this is a pointer variable that points to node, should point wherever first next field points. I repeat it again. First variable, first pointer, the variable pointer variable named first should point wherever, pointer variable should point wherever first was initially pointing to the address that is stored at next. In simple lines, first equals first arrow next. We have this arrow operator in C to access the fields of the node, of the linked list, of the struct variables. We can't use the dot operator like node dot next or node dot something, because this node is a pointer, it's not a struct. It's a pointer to other node. If it was a struct, we could have used the dot operator as we use in struct student or struct something else, whatever you may have done previously. So we will be updating this first to point to the next node and free this block of memory. This frees the head. Now removing in the middle. So suppose we need to remove 22. So we need to update the address of 29 because 34 is pointed by the 29's next field. So PTR is the node that we want to remove and pred PTR is the node just previous to PTR. That is, here in this case we need to remove 22 and 20 is the previous node. So we need to update the next field of the node called 20. I'm just using numbers to call the nodes so that it makes easy to understand. So I need to update the next field of the 20. Next field of the 20 should point wherever PTR's next field points. I repeat it again. Next field of 20, that is the pred PTR arrow next equals PTR arrow next. That is, the address stored in the next field of PTR should be copied in pred PTR's next field. In this way, and free this block, this deletes the 22 and 20 now points to 29. Thus we have achieved removing a node in the middle. So that's the end. uh, Basically the next slide was of the time complexity, that was the big omega notation. So that we will be having another video on that later whenever it is required. So this was linked list. A linked list is just a data structure, and a data structure is just used in software programs to store data for a particular program. Like use a browser, it remembers all the links that you have went through, your passwords. So this data structure is essentially used to store data efficiently and retrieve it without wasting even a single second. In computation, a second is also a second matters the most. If your program is lost by second, your computer can crash, your computer can things can go out of hand. So data structures are just used to get store the data efficiently and retrieve the data efficiently whenever it's needed. So that was linked list. And I repeat it again, you will have the source code for download. I will be posting my website link in the description. I'm rajendra.pythonanywhere.com. So thank you very much. Be sure to subscribe and be sure to share this video whoever needs it, whoever wants to learn linked list.